Welcome back, tech enthusiast. Today we are deep diving into the essential world of Linux user management. By end of this video, you will be a Linux user management pro. So let's jump right in. In today's video, we will unravel the different user categories within Linux. Also, have you ever wondered who you are logged in as? We will demystify that too. Together we will navigate the practical side of managing Linux user through an essential commands, and also will deep dive into the key files pivotal to the user management. So let's embark on this enlightening journey. In Linux, we have various types of accounts: regular users, super user, and system user. Each has its own purpose and permissions. So let's start with regular users. They're also known as standard users or normal users. They have the privileges to manage their files, run applications, and customize their environment. However, they can't access other users' data unless it's explicitly allowed and can't make system-wide changes. Basically, let's imagine public library. Regular users are the library members. They can borrow books, read them, and even make notes in their copies, but they can't modify or remove books from the library collection. Similarly, in Linux, regular users can manage their own data, but they can't tamper with the core system or other users' data. The second type is super users. They are often called as root user. They has unrestricted access to the entire system. This user can read, modify, or delete any file, run any command, and make system-wide changes. Because of this power, it is advisable when you use root account, use it cautiously and carefully. So let's understand this in more detail. Let's say you are using a library analogy again. Here the root user is like a chief librarian or a library manager. They have the keys to the every room, can add or remove books, make changes to the library structure, and even grant or deny access to members. Similarly, the root user in Linux has the power to change anything and everything. The third type is system user. System users are created during installation of various softwares or services. They are used to run system processes and daemons. Typically, these users don't have a login shell, meaning you can't log into the system as a system user. Their primary purpose is to ensure services run with the minimum required privileges, so that it will increase the system security. Think of the behind scenes staff at the theater. The audience and the director, the audience is like a regular user, and the director you can consider as a root user. They see the show from front end, but there are many workers backstage ensuring everything runs smoothly. Lighting technician, sound engineers, stage hands, etc. In Linux, system users work behind the scenes to keep the services running without unnecessary privileges. Understanding these user types is foundational in Linux. It ensures that the right users have the correct level of access, promoting both functionality and security. Just as library or theater needs different roles to operate efficiently and safely, so does the Linux system. In this section, we will delve deep into the understanding who is who on your Linux system. From logged in users to a user's unique identity, we will unravel it all. Let's dive in. The first command is W. It basically shows who is logged in and what they are doing. So in this sample output, you can find the field-wise explanation is: the first one is user, the username of the person logged in, for example John in this case. The second one, TTY, is the terminal type the user is logged in. So in this case is PTS-1, which is a sudo terminal slave. The third one is from, which basically says the IP address or hostname from which the user is access the system. The fourth one is login, the time the user logged in HHMM format. The next is ideal, which basically says how long the terminal has been inactive. The next one is JCPU, which basically says the time used by all processes attached to this TTY. The next one is PCPU, is basically the current process time used, which basically mentioned in the what column. The last is what column, is basically the command the user is currently running. Bash indicates the user is using the bash shell. The next command is who, which basically displays who is currently logged in into the system. So in this sample output, you can find the John is the username person logged in, PTS1 is the terminal type, then the date and time the user logged in, and the IP address of the user. The next command is the Whoami, which basically outputs the username of the current user. So in this sample output, you can find John is the username of the person who is issuing this command. The fourth one is ID, which basically displays the user and the group information of a specified user, or the current user info if no user is mentioned. So in this sample output, you can find the UID 1001 John is basically means that user is associated with this username, and 1001 is the user ID for John. The next is GID. So in this, the primary group ID of the user and its associated group number is mentioned. The next is groups. 1001 John, 27 sudo is basically like all the groups the user is member of with their group IDs and the names. The fifth command is last, which basically shows the last login on the system. So in this sample output, you can find that the username is John, then the PTS1 is the terminal type, then the IP address, the time of the user session, and the duration of the user session. In the world of Linux, every user and group is represented by a unique identifier, commonly known as UID for users and GID for groups. Now let's break it down, what these mean and why these are so essential. As we observe from the ID command result, the UID and GID have a number assigned to them. Let's look at the result of the ID command to learn more about the UID and GID. So let's start with first UID, which is basically called as user identifier. So every user account in Linux is assigned a unique UID. This numerical value ensures that each user's processes, files, and activities are accurately tracked and associated. When a user logs into Linux system, it's not the username that the system primarily recognizes, but the UID. The reason is simple. Processing numbers is computationally more efficient than processing string. While users interact with system using their username, in background, the kernel works with the UIDs. There are various types of UIDs, not exactly the type, but just UIDs. So for example, 0 is for root user, 1 to 99 is reserved for predefined system users, also called as pseudo users such as bean, daemon, nobody, etc. These users run processes and their own size system files. Third one is series is 100 to 999 is reserved for system accounts and groups, including system users added by the software packages. 1000 and above are typically used for regular users, basically non-system users. The next is GID, which is called as group identifier as well. It's like similar to UID, but for managing group permissions. So basically like every group in Linux has a unique GID. Assigning permission based on group membership becomes seamless with GID. For instance, when multiple users need started to an access to a resource, they are assigned to a specific group, and this group is given the necessary permissions. So when the system checks for the group based rights, it's the GID it looks at and not the group name. There are various GIDs or group numbers also. So 0 to 99 is reserved for predefined system groups, 100 to 99 is reserved for other system groups, and 1000 and above are typically used for regular user groups. So now where does the system store these UIDs and GIDs? They are mainly kept in the etc passwd and etc group files. So in etc passwd, each user's account information, including the UID, by default gets stored. We will look into these files in our last section. In this Linux user management command section, we will cover the following categories of command, such as user creation, user modification, user information, and user edition. The first one is user creation. We will kick off this user creation category where we'll explore commands like Useradd. This command is the building block of user creation in Linux. Useradd. So Useradd command lets you add a user in your system, but this command are mostly usable if you are a privileged user. So in my case right now I am a root user, so that's why I can use this command for creating, modifying users. It is not possible with normal user, so for that you need a privileged access. Keep in mind that. So right now I'll use Useradd space John. I'll enter and the user has been created. So if I want to check if my user is created or not, I'll go to the etc passwd file, and on the last line you can find that my user John has been created with the home directory home John and the by default shell sh shell. If you want to know more about shell, please visit my another video, or watch my another video, Shell Explain, which is the link is available in the right hand side top corner. Please visit that video and watch that video as well. So here I want to not just add the user, but I want to modify or let's say set a specific directory for that user. So in this case I'll use the two flag -m and -d. So -m is basically says that if the home directory doesn't exist, please create one, and -d is to set that directory. So I'll set home tnh and then gen and then the new username gen. So if I go to again cat passwd, you'll find that the gen user has been created with the specified directory as a home directory for that specific user. And now let's say I want to change the shell as well. So instead of that D, I will add the S here and I'll say bin zsh. If I mention zsh and then gen2, and if I go again here passwd, you will find that for gen the by default shell assigned because we haven't set any flag, but for gen2 we have used the flag called -s to change the shell, and that's why the shell has been changed for the gen2 user. The next we will move on to the user modification category, where we'll learn how to modify existing user accounts with command like usermod, passwd. These commands allow you to change various attributes of user commands such as password, home directory or login shell. So let's look at usermod command. So let's say I want to change the existing user's directory to a new directory. So I'll use usermod space -d and the new directory name. So for example, I'm changing the directory for John user. That user's directory is home John. I want to change it from home John to gen, and so I'll type usermod -d home gen space username, enter. How to verify that? Like going to the cat etc passwd file. Here you can find that for John user the existing or the current home directory is changed from home to gen. So that's how you can change the home directory using usermod -d command. Then there is a command usermod -l where you can change the login name for the user. So it's basically like usermod -l new username space old username. So I want to change the user's name from John to John Wick. So I'll type John Wick space then the old username, enter, check cat passwd, and here you can find that the user's login name changed from John to John Wick. Then there is a command for changing the shell. So currently my user is having shell as set as a bin zsh. I want to change it from bin zsh to bin sh. So for that I need to type usermod space -s then the new shell name bin sh and then the username. Sorry, I changed the username from John to John Wick, so I need to type here John Wick, and here you can find that yes, the user's by default shell is changed from bin zsh to bin sh. Then there is one more command called usermod space small a and capital G, which is basically adding the user to a supplementary group. So without removing that user from their existing group, you can add them into the supplementary group. So for example, my user Jane is part of the user group Jane, but I want to add that user to the TNH group as well. So I'll type the AG and then the group name, which is basically TNH, and the username. I'll type Jane here. So if I type ID space Jane, you will find here the Jane is part of group Jane as well as TNH. So without removing the group from the existing group, that user, we have added that user to a new group. So that's the usermod command. The next one is the passwd command. Passwd command is basically for changing the password. So if let's say I passwd John, my user's name is changed from John Wick to So I'll type here, let's say I'm typing root as a password, confirming that password. So my password is updated for John. So using passwd, you can change the password for that specific user. Then there is other command in passwd, like you can unlock or lock the user. So if I type, let's say passwd space L and then the username. So this L command is basically locks the user, preventing that user from logging in. So just saying like password expiry information is changed. So basically this user is locked. So John, we cannot log in into the system. If I want to unlock that, I will use the -u command here. The ID command in Linux is used to find out user and group names and numeric IDs given a user's username or UID. It can also provide the primary and or supplementary groups for a user. So let's try out some command related to the ID. So in my terminal, I type ID here and you can find that it's showing me my current user's UID, which is 0, because right now I'm using root user for logging into this specific account. So that's why the ID is showing me the root user as a UID and root as a GID. But let's check out other command also or sub commands for the ID. So if I type ID and the username, let's say I have another user called John. So if I type ID John, it will give me the UID and GID and the groups for the specific user. Here John is part of 4 groups: John, Bean, Mail and Games. So that's why it's showing the different IDs. There are other sub commands or the flags related to the ID command. So if I type ID space -u, it will give me the numerical the UID in number from. If I type same IDG, it will give me the group ID. But let's check out on other user also, because my root user is not part of much group, so that's why we cannot differentiate between UID and GID. So let's try with ID John -u, and it will show me the UID for the John, which is 1001. But the same if I use with G, it will show me 1002, because John is part of 1002 group. So that's why it's showing this. If I want to see the John's various group name, so I'll type ID space John, then capital G. If I enter here, it will show me the various groups in which John is part of. And if I want to see display name instead of numbers, so I'll type ID space John. Can use if I am already logged in as a John, then I don't need to type the John name again and again with the ID. But because I am using root user, that's why I'm typing ID space John, then G and N. Adding N is basically changing the results from numerical format to alphabetical format. So that's why it is showing me now the John, because the group John. Finally, in the user deletion category, we will discuss how to remove user accounts and groups from your system using commands like Userdel and groupdel. The first one is Userdel command. It's used in Linux to delete a user account and related file. This command also modifies the system account files, deleting all entries for the specified user. So let's try that command. So I'll type here Userdel space John. If I enter here, you can find that the user has been deleted, and here you can find that the John user has been deleted from the passwd file. You can verify using etc passwd file. The next is, or the flag in Userdel is -r, which basically removes the user directory and mails pool. So how to use that? Like Userdel space R and then the JN as the username, and you'll find that the home directory and mails, because for Jane there is no home directory or mailspoon is available. So that's why it's giving me error, but I can verify that Jane has been deleted, but as we are seeing some error. So let's try this same command on Jane 2. You just see that there was a Jane 2 home directory is available, and that's why you are getting now error only for the mailspoon, because there is no mailspool for the Jane 2, but there was a directory which got deleted using this command. So if I go here etc passwd, you can confirm that Jane 2 user and its specified home directory has also been deleted. Then there is one more command in Userdel which is -f, or you can say force. It basically removes the user account even if the user is still logged in. It also forces Userdel to remove the user's home directory even if another user is using the same home directory. So if I type here Alex, it will delete the user forcefully even if somebody is using Alex home directory, and you can confirm that here. So Alex user has been deleted. The next command is groupdel. Groupdel is a command like to use for removing the group users or the groups from the Linux system. And how you can use that, like type groupdel and the group name. So we have created TNH as a group. So if I enter here, cannot remove the primary group. Okay, so I'm logged in as a TNH and there is a group called TNH which is primary for this, but you got the idea, like groupdel and then the group name can delete the group. But there is one thing you need to keep in mind, that all these commands require a privileged user access so that you can delete the group or user. So if you don't have that, you may have to use the sudo command before this command so that you can perform the actions. Thank you. The next one in this video is the key files related to the Linux user management. These are some of the files in Linux which are directly or indirectly useful in managing the users and group in Linux. In this category, the first file is etc passwd. It is a main account information file. It contains a list of users on the system and the system properties for each user. So here you will see one sample entry from this file where I'll do the explanation. So in this entry you can find that first one is the username, the second one is the actual password but it is stored somewhere else. After that is user ID, after that is group ID, then the fifth one is the full username, John Doe in this case, then the John's home directory, home John Doe, and then the by default shell whenever this user login can access. So in this case it's been bash. After that the next file is etc shadow, which is basically a secure word. It actually stores the information about the user's password in encrypted format. So in this sample entry you can find the first one is the username. After that the gibberish value is basically the encrypted password. It's basically like your original password will get hashed, basically like transform from one form to another, it's called hash, and the hash will get stored here. This hash is calculated using some cryptographic functions. After that is the last password change. After that is the minimum password age. After that is maximum password age. And the second last one is the warning period, which basically means the number of days prior to the expiration during which the user will be warned. And the last one is the remaining fields. The third file in this category is the etc group. This file lists all groups on the system and their numbers. So here in this sample entry you can find that the first one is the group name. After that is a group password placeholder such as like the passwd file. Then there is a group ID, which basically is a unique number identifying the group, and after that the group list. The fourth one is etc gshadow. Is similar to the etc shadow but for the groups. So in sample entry you can find the first one is the group name, the second one is the encrypted group password, and the last one is the group members. So basically the group passwords are rarely used, but if they are in this group then, or in this specific file. In essence, these files are the backbone of user and group management in Linux. They decide who can log in, which groups they belong to, and how passwords are managed. Thank you for this video. And if you like my content, please subscribe to my channel, like this video, and please comment your feedback in the comment section. Thank you all.